Hello students, I hope you are doing well. This is the first question of my 2025 paper 2 time zone 1. And in this topic, in this question, we will discuss the concepts of the unit A.3, that is about work and energy, and A.2, where we discuss the laws of Newton about the dynamics and forces. So what we are discussing in this question, so as you see the graph, this is the force displacement graph, right? And the one important information about the force displacement graph is that whenever we find the area under this graph or any force displacement graph, this area represents the work done by that force. Okay, so I explain you this graph in a very analytical manner, right? We will relate this graph with an actual scenario, that what was happening with the car during this journey where it covered from 0 meter to 100 meter. So let's assume that a car started. So now you see this diagram where I have shown you that a car having a mass 1600 kilograms starting from the rest. So let's say this is the reference position from where the car is starting. Okay, but remember, according to the graph, at the time t is equal to 0, even at that time, a force of 3000 Newton, a constant force was applied on it. Okay, so this is a resultant force. So I'm assuming, let's say it is in this direction, because this force will produce a constant acceleration, and due to which, do you see that in every next interval it is covering more distance, right? Which is which means that it is accelerating. Okay, so now you can see that until 60 meters, right, a constant force of 3000 Newton was applied on the car, which means that it was gaining velocity because its acceleration is constant. So when acceleration is constant, we know that the rate of change of velocity is constant, so which means that it is continuously uniformly increasing its velocity. So can I say that this is 60 meter? So if you understand this diagram, you will understand this whole one or two questions, right? So this is 60 meter. So it means that at this point, the force was maximum 3000 Newton, and then after this it started to decrease, but it is still positive, which means that the force is still in the direction of motion, but the quantity of the force is decreasing. It means that acceleration is decreasing. So if acceleration is decreasing, it means that now you notice that in every next interval its distance is decreasing. But what about the speed? Because the force is still positive, it means that this force is adding up energy into the system. All right, that's why what will happen, its velocity will keep going on. All right, so it will further travel how much? 40 meters, according to the graph at least, right? Because the total distance is 100 meters. It doesn't mean that at the end of 100 meter it stopped. No, at the end of this 100 meter it have certain velocity. So that velocity is actually we need to calculate according to this question. So now you understand it very well, that what is the area represented under this graph, which quantity represents this area. So that area is represented by the work done by the resultant force, right? And you can also get an idea, because if I find the area, right, so we see that this is the area under the rectangle. So I have to ultimately multiply the two quantities. The one unit is Newton, another unit is meter. So Newton meter is equals to joule, and joule is a unit of work done. So this is the answer of the first question. Now let's move to the understand the second question, find the final speed of the car. Now dear students, remember I told you at this point, at the 60th meter, what was the force? Force was a constantly applied 3000 Newton on it. But after the 60 meter, this force reduced to, I mean, it is continuously reducing as you see from this diagram. But I told you that it is still increasing its velocity, right? So just for more clarity, right, remember that the velocity time graph will be straight line until 60 meter for a certain time, the time that it will take. And after this, this graph will be a curved like this, so that if you find its slope or gradient, it will represent that acceleration is decreasing. All right. So anyways, now how do you find the speed of the car? So it is only possible if you apply the work energy principle, right? Because we cannot apply Seurat equations, because you know that the force is variable after 60 meter, right? So acceleration is not constant after 60 meter. So it is a good approach if you apply the work energy principle, and work is equal to the change in kinetic energy. Now this work done is equals to the final kinetic energy minus initial kinetic energy, right? And this work done is equals to 1 over 2 mv square minus 1 over 2 mu square, right? And you know that the initial velocity is 0, so initial kinetic energy is 0. Now the question is a big question: what is this work done? So this work done, don't you think, is the area under the graph? Area under graph, right? And that is equal to, if you apply the direct area of a trapezium, because this is a trapezium, all right, or you can in other case you can divide this whole area into the two parts, the area of this rectangle and area of the triangle, all right. So if I apply direct formula of area of trapezium, then the area of trapezium is 1 over 2 sum of parallel sides. Now which two sides are parallel? This side is parallel to this side, right? The length of this side is, you can see, 60 meter, right? So I will say 60 plus the length of this side is 100, right? So it is 100 times multiplied by the height, okay? So this thing, right, which you know is the 3000, okay, is equals to 1 over 2, mass is 1600, and the v square. So if you solve it, it is 240,000 is equals to 800 v square, and v square is equals to 240,000 over 800. And if you want to find the speed, the final speed at the end of 100 meter from the reference point, then this will be the speed. So the answer is 17.3 meter per second, which we will approximate. We can write it is 17 meter per second. Okay, so this is the speed, final speed of the car according to this graph. Now here comes the second part, that where we will discuss the resistive forces. How does it affect the power, and how can we find the speed? Let us find it. So in this question, they are saying that if there's a different car which is traveling horizontal on a horizontal road with a speed of 45 meter per second. Now they are saying at a constant speed of 45 meter per second. So if the speed is constant, then it means that the acceleration is 0. And if acceleration is 0, it means that sum of all forces equals to 0, right? And sum of all forces equals to 0 means that the two forces applied on the car in the direction parallel to the direction of motion are equal. Let me show you in this diagram. So students, let's say the car is moving to the right, and these are the streamlines of the air, right, which are opposing, right? So this is because air is a fluid, so car is actually traveling against the direction of this air. So that's why this air will result a force, right, which I can say the force resulted by this air is the resistive force, FRES. Okay, according to the question, it is this drag force is equal to CV square. Okay, but they also mentioned that it is moving with a constant velocity, which means that the force applied by the engine is exactly equal to this force, resistive forces, in order to keep this car moving at a constant speed, right? So these are the two forces which are equal. All right, now what power we are continuously providing by the engine to maintain this state of motion? That is 140,000 watt. Okay, so it means that, and in this question we have to determine the C. Now, how can we relate the power with the force? If you remember that the power delivered, if a car or if a boat or if any object, despite of the resistive forces, is moving at a constant speed, then we always say that the average power in that case is equal to the product of the force and velocity, right? Now in here I will write the force of engine, but it is, since it is equals to the drag force, right, times v, okay, and power is equals to cv square times v, okay, and we want to find c, so c will be equals to power over v cube, okay. So here you can plug the value and find the answer, but remember we don't know the unit, okay. For this we will do another procedure. So the answer of the this coefficient is 1.5, but what should be the unit? Let's check it, okay. So for this, we will, of course, we have to derive its unit from its equation that we have made, and we have to find its unit in the form of fundamental SI unit. So C, is equals to the power over V cube. In terms of units, the power unit is watt, right? And speed unit is meter second raised power -1 and its cube. Okay, now the watt is equals to joule per second because work over time. So joule per second divided by meter cube and second raised power -3. Okay. Moreover, joule is a unit of work done. That is a product of force and displacement. So that is a product of Newton meter. Joule is equal to Newton meter. Second raised power -1 meter cube and second raised power -3. Okay. Now you may cancel out this meter with meter cube. It will result Newton over meter square. Okay, and when you will combine this and this one, right, it will be -1 plus 3, so Newton second square over meter square. Now Newton is a unit of force, and that is equals to mass times acceleration. So Newton is equals to kilograms meter second raised power -2 times second square over meter square. So dear students, this one is cancelled out, and finally what we got is this thing, right? So now we should write here kilogram meter raised power -1. This is a complete answer of this coefficient C. So this is a mark scheme that's explain this thing, and this is a unit, and we have, I think, understood this thing in a very well manner. I hope you understand, and see you next question.